We have bond parameters now. What is bond length? These are the bond parameters we're going to discuss. I'll be covering resonance and polarity in the next video. Now I'm covering very quickly these four concepts, bond parameters. Now, the first one is bond length. It is defined as the equilibrium distance. This word is very important between the nucleus of two bonded atoms. Like, let us suppose I have this chlorine and this chlorine. Any molecule you can consider hydrogen, hydrogen, or chlorine, chlorine. So when the two atoms combine, the equilibrium distance between the nuclei is what we call as bond length. And what is the purpose of equilibrium word? Just understand when two hydrogens are present at infinity, that means they are present at large distance from each other. They are present at infinity. There are no forces, neither attraction nor repulsion. Infinity means they don't know each other. Like let us say I'm talking about my emotion with a stranger or your emotion with a stranger. You don't know a stranger, so you have neither like nor dislike. But whenever two people come closer, right, strangers, to the process of becoming friends, you become friends when you experience some forces of attraction. So similarly, when two atoms approach each other beyond one distance, the nucleus of one starts attracting the electron of the other and vice versa. So forces of attraction are built in. And attractions lead to a lowering of energy. Let us say these were atoms at infinity. This is distance. As they come closer, they face attractive forces. Attractive forces are going to lead to decrease in their energy. Okay. So, but when they approach very close to each other, they might start experiencing repulsions between these two heavy positively charged nucleus. So if I start bringing them closer beyond a distance, their energy will start increasing. Why? Because the nuclei will start repelling each other. So the equilibrium distance where attractions and repulsions are in equilibrium, that means balance each other, that's the distance where a bond is formed. And this distance is what we call as bond length. Right? So the purpose of this word, this is very important word in the definition. It's defined as the equilibrium distance between the nuclei of two bonded atoms in a molecule. And how do we measure? These are the methods we use for measuring. We cannot see them with the naked eye. So spectroscopic methods, X-ray diffraction, and electron diffraction techniques are used to measure bond lengths. Now, these are the comparison of bond lengths. And what do you need to really understand? You can observe a double bond length is always smaller than a single bond length. Single bond means less forces of attraction. Double bond length, double bond means more force of attraction. Two bonds are formed. So the atoms come closer. In a single bond, they are further away. Double bond, they are closer, and triple, they are still closer. Because extra bonds means more attractions. The atoms are coming closer. So multiple bonds are, you can understand, bond length is inversely proportional to bond order. More bond order is a smaller length. Okay, so these are some bonds given to you for comparison. You don't have to learn, but you should be able to predict the orders. And similarly, we have some examples here. If you look at, like, supposing I ask you to compare these three bond lengths, you know H is common to all three, and F is the smallest sized atom. Chlorine, chlorine, bromine, iodine is a halogen family. Larger iodine means a longer bond. Clear? So similarly, if I'm comparing oxygen molecule with nitrogen molecule, I know nitrogen is a triple bonded molecule and oxygen is a double bonded molecule. So nitrogen has a smaller bond length than oxygen. You're not supposed to know the actual values, but you need to know the comparisons. So this is how you will diagrammatically show it. If you're asked this question or write a note on bond length or express the definition, this is how we find out bond length. R is the bond length. What is it? It is basically the sum total of covalent radius of two combining atoms. It can be defined as the sum total of covalent radii of two combining atoms as well. What is bond angle? Bond angle is defined as the angle between orbitals containing bonding electron pairs. What is bond angle? It's angle between bonded pairs. For example, if let us suppose I'm talking about water, water has two bond pairs and two lone pairs. So bond angle is going to be the angle between the bond pairs around the central atom. Oxygen is the central atom. This is the central atom, and the bond between the bonded pairs is what we call as bond angles, expressed in degrees, measured by spectroscopic methods, and it also helps to determine shapes of molecules. Bond angle depends on hybridization, as well as bond angle depends upon, for the same hybrid state, bond angle also depends upon electronegativity. Just remember, bond angle around central atom increases with increase in electronegativity of the central atom. What does it mean? If I ask you to compare the bond angle of NF3 and PF3, same hybridization, similar hybridization, similar steric number, 3 bonds, 1 lone pair, 3 bonds, 1 lone pair, everything is the same. But bond angle is going to be more here because nitrogen is more electronegative than phosphorus. So more is the electronegativity of the central atom, more is the bond angle. Simple explanation, if the electronegativity of the central atom is high, this shared pair is going to be more closer to nitrogen. And when these bonded pairs are closer to nitrogen, they will repel more. And hence this bond angle is going to increase. Whereas in case of phosphorus, this same shared pair is going to be a little towards this side because phosphorus is less electronegative than nitrogen, which means these electron pairs are a little far away from each other. Clear? Now, similarly, if I talked about bond angle between NF3 and let us say something like NCl3, I'm not talking about any other factors, just focus on the electronegativity part. This time, the electronegativity of the central atom is the same, but surrounding atom is more electronegative here. This is less electronegative. So this time the electron pair is closer towards fluorine, and here it is closer towards nitrogen. Yeah, so the bond angle here is going to be more. Bond angle is going to be more in this case. So the point says if the electronegativity of the central atom is more, bond angle is more. If the electronegativity of the surrounding atom is more, bond angle is less. Just remember this point to compare this. So if I ask you to arrange these in order of their bond angles, what are you going to do? You're going to simply compare them in terms of their structures. Methane means 4 bond pairs. Ammonia means 3 bond pairs and 1 lone pair. Water means 2 bond pairs and 2 lone pairs. And all these three have the same hybridization, which we are going to study ahead. Same hybridization. Fine. So more lone pairs are going to decrease this angle because they will repel more. This point will be a part of BBT and vesicle. So right now, if you want, you can just leave it. But if you understand it, fine. Ammonia, this is going to be the bond angle part. Why? This is more lone pairs, therefore lesser bond angle. And then, what is the normal tetrahedral angle? 109 degree, 28 minutes. But BF3, steric number 3, the bond angle is going to be 120. And if I'm talking about ethyne, the bond angle becomes 180. So that's how here the bond angle differs based on the hybrid state of the molecules. This was sp2, this is sp, and these were sp3. So either bond angle depends on hybridization or it depends on the electronegativities as we have just discussed. So if I ask you which out of these has the largest bond angle, what are you going to see? The electronegativity of the central atom is different. Otherwise, nitrogen, phosphorus, arsenic, antimony belong to the same group in the periodic table. Their structure is same. Each has 3 bond pairs and 1 lone pair. So what will decide more electronegativity of the central atom? More is going to be the bond angle. So ammonia has the highest bond angle. So next we have bond enthalpy. Now this is a very important question for school exams. This can be asked as such. What is bond enthalpy? We are going to basically talk of bond enthalpy and average bond enthalpy in this topic. Okay, bond enthalpy or bond energy. So it is defined as amount of energy required. Amount of energy. It is defined as the amount of energy required to break 1 mole of bonds between atoms in a gaseous state. Unit of bond enthalpy is, since it's an energy, kilojoule per mole. Okay, so this is one example of, you can just keep an idea that the HH bond enthalpy is in the order of 400 range. Clear? So it's basically the energy required to break these hydrogen molecule into 2 hydrogen atoms. Clear? Now, if we have polyatomic molecules means something like, let us suppose, methane or water molecule. If we have molecules like methane and water molecule, then we are going to talk of average bond energy, right? Because in polyatomic molecules, we are going to use average bond enthalpy term. Why? Because we have more than 1 bond, and each bond is going to have slightly variable bond energy value. Clear? For example, in water, the energy required to break this bond is going to be 502. But if we have to break the next bond, the energy required is going to be a little less. Why? Because after breaking 1 bond, the bond is going to become weaker. So the next one is going to require a slightly different energy. Fine. So just to be clear about this, there's a difference between average bond energy and bond energy. Clear? I repeat, if there are 2 bonds in water, this energy is bond dissociation energy. This is also bond dissociation energy. Each of these is bond dissociation energy. But if I take average of the 2, it's going to be bond energy. So bond energy is nothing but average of the various bond dissociation energies. Is it right? Yeah, and bond order we've already talked of. And just remember, isoelectronic molecules will be having identical bond orders. That means if the same number of atoms are the same number of electrons are there in molecules, the bond order is expected to be the same. For example, if I'm talking about carbon monoxide and cyanide, this is 4 plus 6, 10, and this is 4 plus 5 plus 1, 10, which means both carbon monoxide and cyanide ion are going to have bond order equal to 3. So isoelectronic molecules and ions have identical bond orders. This is going to be very important for you to decide the concept. And bond order is directly proportional to bond enthalpy, and it is inversely proportional to bond length. This is the point I've already expressed.